Welcome in, everybody. We are at week 9. We're going to cover something pretty cool today. It's called reading and writing files. So the context behind this topic is we're finally going to have data that lives in another place. Lately, we've been kind of hard coding data into the source code. So for example, recall back from the dictionaries lesson, right? So this is a long time ago. You might remember we declared some dictionaries, like right here. This is a dictionary that contains 3 key value pairs, right? It's pretty much mapping names to their scientific name. This is an example of a hard-coded data, a hard-coded dictionary. Meaning that the data lives in the source code. If the data were to change, we would have to edit the source code, which could get kind of tedious. So the theme of today will be kind of loading data in from somewhere else. Right. So here, before I jump into today's lesson, right? So today's lesson is on number 13. All right, I'm not even going to open this up yet. I'm actually going to kind of start off with a context and then do an example. Right? I'm going to do an example that's going to seem a little overkill, but it's going to give us some context on what's the purpose of this topic. Right, so you don't have to open up this notebook yet, as long as folks are kind of following along what's happening. I'm going to go ahead and create a brand new notebook. So let me exit all of these. I'm going to create a notebook in examples over here. Right, this is a folder. Okay, I'm going to create a notebook here. Let me call it. Let me rename this. I'll probably call it. Let's see. I'll probably just call it Data Analyzer. I can't think of a good name, but this notebook is really just going to show an example of kind of reading data. Okay, I'm going to start off with a hard-coded example first, right? Meaning that the data will live in the source code. You might remember from a long time ago, I pulled up an example of a data that's stored in a JSON. A JSON is a popular format for storing data. Right? It stands for JavaScript Object Notation. It's really just you can think of it as a formatter, right? Like here's an example of what a JSON file might look like. So scrolling down here, right? This is an example of what it might look like. You can think of this as kind of like a nested dictionary, right? So you see how there's a bunch of key value pairs, right? There's the first name, which matches to John, right? That's the value. Another key here gives us the Smith value, right, and so on. There's some nesting going on here, meaning that there's a dictionary inside of a dictionary. Right? Like going down to this address, right, this is the key. What is the value? Right? You see how the value is another dictionary? That's what I mean by nesting. Right? It's possible to have data structures within data structures. So you might have remembered a long time ago, I ended up kind of copying this whole thing. All right, so let me just copy this whole JSON file. All right, so there it is, and then you can actually paste this into the notebook and change a couple things, and you can actually read it as a dictionary. All right, so there you go. I just pasted it in here. I'm going to say that this whole thing is equal to data. So over here, I said data is equal to the dictionary. All right, once again, this is hard coding. Right? Data is a dictionary that contains all of these. If anything, I do need to change a couple of literals, like this true. In Python, the literal is capital, so I gotta capitalize true right here. And then there's another literal down here. This keyword isn't compatible with Python. Python uses something called none. Okay. Cool, so I'm going to go ahead and run this cell. There it is, I just ran it. There's no output, but it did create a dictionary called data, right? So let me go down to this next cell. right? See, I could look at the type of data, right? Type of data is a dictionary. We could look at more stuff, right? Like if I just kind of dump the whole dictionary out here, it's going to give us the whole thing we kind of pasted over, right? This is a dictionary. Right? You could list out the keys. So in dictionaries, it has a keys function, right? This will tell us what's available, right? In this case, it's kind of like a list of keys. Right? We can access any of these features. Like you might remember, you can access things in dictionaries with this kind of like a list, right? You basically put these square brackets and then index it by its key name. Right, so first name, this is going to give us the value, right? John, right? Which makes sense because it's saying, hey, what is the value associated with this key, right? It's John, and then so on, right? You could say last name, Smith, and then let's kind of go on to the more nested stuff, right? Like address, right? Let's go ahead and see what value address gives us. Okay, so I'll type in address here and kind of just look at it. So press play, and there we go, right? You see how it's another dictionary, right? It's not a singular value. So this is some nesting. Right? Just to prove it is a dictionary, I'm gonna wrap in a type. Right, so wrap in a type, yeah, see, it is a dictionary. And if you want, you can look at the keys, right? There's only 4 keys here. Hopefully people can see that, right? Street, city, state, and postal code, right? So you could look at the keys. So I'm gonna look at the keys in here, and there's 4 of them, right? Street address. So if you want to kind of dive into this dictionary, you can use another square bracket, which will go into it. Right, so I could say, oh, what's the city? So address and then city gives us New York. All right, so once again, this is just an example of hard coding data and kind of navigating your way through it. Right? In this case, we dived down 2 dictionaries. Right? We went into the address, which gave us another dictionary. And then we went into a city, which gave us a singular value, New York. Okay. So yeah, that's all we really did so far, right? We have data that's hard-coded. It lives in the source code. It might be more general to not have the hard-coded data here. Data can live in other files as well. Like, I'm gonna download some files actually. So before that, I want to introduce folks to something called a CIA fact book. So for people who are not familiar with CIA, CIA stands for Central Intelligence Agency, right? It's like one of those federal things in the United States. The CIA, they have a resource called the World Fact Book, which is pretty much a website that contains data on a lot of regions. All right, so I'm going to look at the CIA's data here. I see here it is, CIA.gov. It pretty much provides basic information about the world. All right, for example, I could go to countries, right? Go to countries, and then let's see, Antarctica. Right, Antarctica, here's some data right here. So I'm going to click on Antarctica, and you see all the data right here. Right, it says, oh, background. Right, this is the background of Antarctica, and then going down, there's some statistics here, like the area is this, right? The coastline is this number. Natural resources, right? Natural resources in Antarctica is a kind of a list of things. Right, they got iron, they got some other metals, nickel, platinum, they got coal, right? But pretty much what I'm showing here is some data. Data can live somewhere else. So what if we were to kind of download this data into our Python notebook? Right? Would it be possible to, access these elements? There is, right? Someone actually wrote a tool that scrapes this data. So someone wrote a tool, it's pretty much a web scraper, right? For people who have heard of what web scrapers are or haven't, web scraping is a way of kind of extracting data from websites. So someone wrote a tool that scrapes data from this CIA website. Right? You can check this out. It's stored in GitHub. GitHub is a place where people kind of store their code. So GitHub and then CIA Factbook. So I'm gonna look this up real quick. CIA World Factbook. Okay, so here is a person or an organization that kind of scraped the data for us. So I'm gonna click here, factbook.json. This is a repository. It's like a folder of files. That's pretty much what it is. In particular, here's Antarctica. Right, so I'm gonna click into the folder Antarctica. And you see how there's a few JSON files in here. These are really just data files that kind of represent different things. I'm not really sure what the AY means or BV. Whoever organized the data, I'm not sure what these stand for. But looking at ay.json, just clicking into it, this is a text file. And it looks like it contains information that we just looked at. Right, so just to prove it, I'm gonna kind of load it side by side. Okay, so this is the text file that someone uploaded. And then on the right, this is the CIA Factbook. Right, so I'm gonna look at Antarctica again. Just to sanity check. Right, sanity check what's happening. Okay, cool, so I'm on Antarctica. And here's the background, right? The background, there's some data. It says, oh, speculation over something. Right, here it is, right? On the left, see? It looks like the text file kind of represents this website here. And then kind of scrolling down a bit more. Let's see, just kind of sanity checking things. Let's see. Let's go a little deeper. Natural resources. Let's see if this is stored in the JSON file. So natural resources, kind of scrolling down. Here it is. It looks like there is a key value pair that gives us, a key value pair that gives us the information. All right, so this stuff is this right here on the right. Okay, cool. So hopefully people kind of see what I'm showing here. It's pretty much just a person who scraped the web for it, right? So if I were to back out to the root of the repository, right, you see how there's folders that represent a lot of other regions. You can access data on other countries as well, right? You just gotta kind of narrow it down. For this case, I'm actually going to go into Antarctica and then download this file here. Right, I'm planning on downloading this into the Jupyter server. You don't have to do this, but one way you can download it is there is a download button right here, right? You can download it and then upload it to your server. But I'm actually gonna skip that step and just do a command that will download it right away. So I do need the URL of the raw file. So I'm gonna click on raw here and then copy this URL on top. So on top, there it is, copy. And this URL represents the source of the file. So I'm gonna go ahead and download this file. You can use a Linux command over here. So I'm here in the notebook. You might remember last week I pulled up a terminal. Right? So this terminal down here lets us type commands and kind of interact with the computer. Right, this is not Python, by the way. This terminal is not Python. It's actually called Bash, which is a different language. It's a language where it lets you communicate with the terminal. So here I'm going to use a command called wget. Wget stands for webgit. It's a tool that will let you download from certain URLs. Right? Oh, and real quick, if people are running this command, just make sure that you're in the right directory. Right? When I type in wget something, it's going to download some data and put it in our examples directory. So basically, I'm saying that if you're accidentally in the wrong directory, like let me type in cd. Right? CD with nothing means it's going to bring us home. Right? C. So I type cd. This brings us home. Right? If I do ls, right, ls will list it. List And it's, yeah, I need to dive into here. So I need to go CD into CIS-15, and then I need to CD into examples. Whoops, CD into examples, not exams. And there we go. But the reason why we want to be inside of this directory is kind of so we can have the notebook close to the data. Because when I type in this command, wget and paste, right, there it is. Check this out. So wget paste, this is going to download the data we just saw. All right, so enter. Okay, and see here on the left, if you go ahead and refresh this, right, you can click on this examples here. It's going to refresh it. So there it is. Right, just refreshed it. You see this brand new file here. Right, this brand new file is called a.json, ay.json. This is the file that we just downloaded from that person. Right, so you could look at it if you want. Right, you could right-click it and say open with editor. Right, so I'll open it with the editor, and yeah, here it is. Right, it's literally just text. Right, this JSON file is text that we downloaded, right, from this GitHub. Right, once again, this GitHub is made by some person who scraped the CIA website. So here's the file. The data no longer lives in the source code. Right? It lives in a JSON file. So the cool thing about this is we can load this file in. This is going to be the theme of today. Whoops. The theme of today will be loading files from other places. Right, so going back to this data analyzer, this was hard-coded data. So I'm going to get rid of it and work with the file that we have. So there it is. I'm just going to delete all of this. Let me clear these cells. Okay, so you don't have to understand this yet. This is just going to give a sneak peek into the future. Right? So this will look a little overkill, but you'll understand it in just a bit. So we're going to see this command in like 15 minutes. There is a function called open. Right? Python provides a function called open, which takes a couple arguments. The first argument represents the name of the file that we're opening. So in this case, I'm going to give it the name ay.json. Right? This is kind of like telling Python to double-click this file. Right? So open JSON is literally like saying open. Right? So it's kind of like saying right-click and open with editor. Right? That's pretty much what it is. Okay, so there it is, open. There is another argument that you don't really need, but this other parameter represents whether or not it's going to be in read or write mode. Right? So they're opposites. A read means we're going to kind of only load the data. Right? So read, so I just put an R here as a string, meaning that I'm not planning on writing to the file. Right? I'm not planning on adding any information here. So I'm read only. This function returns it's kind of like a pointer. You can store it in whatever variable you want. I'm going to name it file handle. Right, so the reason why is because this function open, right, it kind of returns like a thing that you can use to modify or work with the file. So file handle is pretty much like saying a tab, right? Like you know how these up here, these are all tabs. File handle is like keeping track of the tabs for us. So we can use the file handle, and oh, you know what? It's actually good practice to close it for every open. I'll talk about this in just a bit, but this is like saying every time we open something, at some point you're gonna have to close it. Right? Otherwise, you'll have too many open tabs. Okay, so can you imagine how like you'll have a bunch of open tabs like this? Right, see all of these? It's probably a good idea to close them at some point. So that's kind of the analogy I'm making here. And then in between, I'm gonna kind of do some magic that will make sense in just a bit. So I'm gonna go ahead and create a dictionary called data, and then set it equal to the file handle. Right, but I do need to convert the file handle into something. There's a library that lets us convert it from JSON. Right, so there's a library called JSON. It's included in the regular Python. This module or library will let us use a function called load. Right, load takes some sort of argument. The argument here represents like a pointer, like the handle that you want to look at. So in this case, it's file handle. Right. So there we go. Right. I'm saying, hey, create a dictionary, name data, and then the right side. This is a function that converts a file handle into a dictionary. So let me go ahead and test this real quick. So I'll press play. Okay, cool. It runs. It didn't really have any output because all it does was, open, store the data into a dictionary, and then close the file handle. So the data is actually kind of big now. Right? I can actually look at the data right here. Right? Let me look at data in another cell. And here it is. Right? Here's Jupyter Notebook showing us the result. Right? The result of the last run statement is just the nested dictionary. People kind of seeing what's happening. Okay, cool. So yeah, there's our dictionary, right? Just to prove it, it's if I go type data, right? This is a dictionary. We could look at as keys. All right, let's look at as keys. So the keys here, there's like several of them. Let me go into maybe economy, right? Let me just kind of see what's going on here. So let's look at the economy. So data, economy. Oh, it looks like it's empty. Interesting. Let me sanity check this. I'm surprised this is empty. So I'm actually going to load up the raw file here and kind of see what's happening. So here's the raw file that we're working with. And I looked at the economy. Oh, okay, that makes sense. So basically when the CIA wrote the website, I guess they didn't have an economy section. So the person who web scraped it, there was nothing here. Okay, so that makes sense. Let me look at a different key then, because that one's empty. Okay, let me look at a different one. Maybe geography. Let's look at geography. So data and geography. Okay, cool. So there it is. It's another dictionary. You see how it's kind of nested, right? Like by saying data, geography, that's pretty much like saying this right here. So this is the data, right? And then by saying geography, it's saying, hey, grab the value from this, right? The value is pretty large, right? The value is everything underneath here, right? It's all of this, all the way up to the ending brace. So it's all the way here, I believe, right? This whole thing. Wait, is it? See, I gotta line it up. Anyways, it's big. So let's go a little deeper. Let's look at the keys for this internal dictionary. Let's see. So there's some more here. Let's look at natural resources. Right? I'm curious what the natural resources are for this Antarctica. So let me index into it. Right, natural resources, and let's see. So enter, play it. Okay, it looks like we're one more dictionary in here. Right, this dictionary, it looks like it only has one key value pair. It's called text, which gives us kind of like a long string here. All right, so let me index into here, text, and there we go. Right, this is finally giving us some data. Right, this is just a really long string, by the way. Right, you can confirm this by looking at the type. All right, see, it's a type string. Okay, cool. So we're kind of just, all we did so far was download data. It lives in a separate file, right? And then we made a notebook that kind of opens it, converts the file into a dictionary. And now we're kind of just navigating the dictionary. Right? This is some useful stuff, by the way. This is, you can imagine this as an application where you can kind of ask for features on different regions. right? And kind of just a little side tangent. This is a string. If you wanted to convert this to a list, oh, you could, right? You see how these are kind of comma separated? You might remember from a long time ago that strings have a split function. So this whole thing is a string, meaning I could do a dot split here. Right? Dot split means it's gonna, well, it needs an argument here. Right? The argument represents how to split the string. So I'm gonna split it based off comma space. Right? So this split function is going to give us a list. Right? So check it out. I'm gonna run this. You see how it's giving us a list? Right? It pretty much took this string. Right? It took, here, let me rewind. Right? It took this string, right? And then for every comma space, right, it kind of ignored that and kind of separated things into a element. Right? So split based off comma space, right? This gives us a list. Right? You could store this list into something like maybe I'll call it natural resources. Right, so natural resources is equal to this, and then see, I just pressed play. It doesn't do anything because I need to print the natural resources. Right, so natural resources. Whoops. Natural resources. There we go. I see it's a list of separate things now. So yeah, this is some useful stuff. If folks were curious about these kind of magic stuff here, I'm not really going to test folks on reading JSON files, but when I load up the notebook later, we're going to be dealing with simpler files. This is kind of like a sneak peek into the future. At the very, I think the last 2 weeks, we're going to cover something called data structures. So lesson number 19. This is the second to last lesson. This is what we're getting a sneak peek into right now. That's really what it is. Okay, any questions about this sneak peek? I do know that this is a little overkill for the example, but the theme, as long as people sense the overall theme, right? The overall theme is we are working with data that lives somewhere else. In this case, it lives right here, right? Data analyzer. This is the notebook. And it depends on this file that we downloaded. Pretty cool, right? Pretty cool, okay. All right, let's go ahead and jump into the actual lesson today. So the actual lesson today is number 13. It's going to be working with reading and writing files. And it has a lab associated with it, number 13. So let's go ahead and load it up. Okay, so I'm going to go ahead and quit this notebook. Okay, lessons, and then lesson 13, files. Okay, let me clear this kernel real quick. I think I ran something from the previous. Okay, cool, just cleared it. Okay, let me go ahead and run this first cell. It's going to let us draw stuff. Okay, cool. So I just ran the first cell. So yeah, this notebook is talking about, reading data from other places. In this case, we'll be reading data that is stored in the storage. Okay, not the memory. But basically the storage is right here, right on the left. This is all stored on, some hard drive. So that's pretty much what I mean, right? We're going to be accessing files that are in the storage. Okay. So we need to talk about something called paths. Paths, you can think of it as a string that represents the location of a certain file. Right? For example, you see this image.open right here. Right, this is saying, hey, open a file in this path. Right, so this is a path, and it is relative to our current working directory. Right, what is our current working directory? The current working directory is where this notebook is located. So you see how this notebook is named 13 underscore files? Right? It's located right here. Right, it's located right here inside of this path. Right? CIS-15 and then lessons. So what I mean by relative is that this line of code right here, this is accessing a path relatively, meaning that we start at this directory. So by going into images and then this PNG file, it's really saying, hey, go into this folder, right? This is a folder, so go into it and then access the Python list.png right here, right? This is just a picture, right? If you're curious what the picture is, you can double click it. Wait, can you? Let me double click this. There it is, right? I just double clicked it, and here's the Jupyter Notebook showing us what this image is. Right? It's really just an image that was used as a dependency in another notebook. So just an image. There's more images here too, like Forrest Gump. I'm not sure why this one's here, but this is a picture. And you can open it if you want, if you specify the path. Right? So the path is inside of images, and then is right here, right? You got to change this name to Forrest Gump.jpg. And then if I run this, it's going to give me a picture of Forrest Gump. Okay. Wait, is this Forrest Gump? Yeah, it is. Okay. Yeah, people kind of seeing what a path is, right? It's like a string that represents the location of something. This is a relative path, by the way. Sometimes you might want to go backwards from the relative part, right? Like, here's our current working directory. Right? Current working directory is in lessons over here. What if we wanted to access something that is outside of here, right? Like this path is going inwards, right? It's going into images and then into this final file. But what if we wanted to go outwards, right? Like meaning backwards. Like if I wanted to grab a file that's back over here in the CIS-15, right? Like let's say we go back CIS-15, and maybe there happens to be some file here, right? So here, you know what? Let me actually put a random picture here. Let me think of a picture real quick. I'm just going to download the Cabrillo College logo. Let me just download the Cabrillo College right over here. This is a PNG. Let me just download this picture. Save as Cabrillo logo. Okay, so I just downloaded the logo. I'm going to upload it to my CIS-15 over here. So kind of drag over here. Cool, so I have a Cabrillo logo in my CIS-15 directory. How do I open it? Right, like if I were to, would it work if I just say Cabrillo logo.jpg? Right, this is not going to work. It's going to say, hey, file is not found. Right, it says error, no such file or directory. Cabrillo logo.jpg. Right, so the reason why this error is happening is because of an issue with the path. Right, this path is supposed to be relative to the current working directory, which is right here in the lessons. Right? There is no Cabrillo College logo in this directory. Right? You could put it into here. You could kind of just drag it into this folder and it will work, but for the sake of demonstration, you can just go backwards. Right? The way we go backwards is saying .. This is like if you're familiar with Linux or Unix, or kind of just, if you're familiar with using the command line at all, you might be familiar with what .. means. Right? It just means go backwards from the current working directory. So let me play this now. And there it is, right? It successfully opens it up. Right? So once again, this is a relative path. This is saying go backwards. Right? So go backwards is like saying here, right? Go backwards, and then access the JPEG here. Right, so hopefully people are seeing what's going on. Okay, we can access more things too, right? Like we can say access the maze.png, right? So let's kind of navigate from there, right? So we start at lessons. This is like saying, hey, go backwards. Right? So backwards, boom, there it is. And then go into labs, right? So labs, and then files. So double click into files, and then finally maze.png. Right? So that's going to kind of load this in. Right? And there it is. Are people cool with this so far? Just a maze. Okay, the whole goal of this is really just to talk about paths. Right? We talked about something called a relative path. Right? Relative paths mean that they start from where a notebook is located. Sometimes it's necessary to use absolute paths as well. It's kind of like a different style. This first path right here is not absolute. Absolute paths start from the root. Right? You see what I mean? This path starts from the lessons directory. Right? It starts from here. Right? This is not the root. Right? The root is the furthest back you can go. If you're curious what the root kind of looks like, you can load up a terminal and type in pwd. Right, so I'm looking up here. My prompt is inside of lessons. You can type in pwd, which prints the working directory, and it'll tell us the whole absolute path. Right, so in this case, the whole absolute path is /home student CIS. All right, so I'm just going to copy this. All right, so let me copy. All right, that's the absolute path. And then let me paste it over here. All right, so this is literally the same thing as saying image.open home students lessons images and forest gump.jpg. So both of these are the same. They're the same lines. Let me comment this out real quick just to show it. All right, so I'll comment out the first one, and here's the second one running. All right, so it's the same thing. Basically, the difference is this is accessing a path, absolute path, meaning that it starts from the root. Right, the root is the furthest back we can go, which is all the way home, student. Okay. Let me see if I can go back here. So the furthest back we can go is right here. See, this is home, and then a student. Oh, you know what? You can't even go backwards. No, so we're actually inside of student right now, but I guess you can't go backwards because of security hazards. Otherwise, you could view other students' stuff. But yeah, you can type in pwd in the terminal, and it'll show you the absolute path. Okay. Anyways, hope that makes sense so far. We talked about kind of opening places, opening things in different locations. Let me go back to the original working directory. Okay, cool. So we can open files. We saw earlier something called a file handle. A file handle is kind of like a variable that gives us access to work with a certain open file. Right? Like if I were to go ahead and open up this text file here, right? So check this out. Once again, there's a function called open. You give it the path of whatever you want to open. In this case, I'm going to give it a relative path, example.txt. All right, so this is saying, hey, go into files right here. All right, so go into here, and then go into example.txt. All right, so let me check this out. Right? I'm just going to double click it just to see what's here. So let me double click it. There it is, right? It looks like it's a text file that contains a poem, right? A six-line poem. So yeah, it's literally just a text file with 5 lines. Cool. We're planning on opening this file up in read-only mode. So you actually don't really need this. The second argument is R, which stands for read. Right? You don't really need this because it opens it on read-only mode by default, but this kind of makes it a little more readable. Right? It pretty much lets everyone know. Let's It's just more explicit. That's all. So open it in read-only mode because we're not planning on writing to it. Right? So far, just kind of reading. This open function does return a file handle. Right? You can call it whatever you want. Right? You don't have to call it file handle. It's just a variable that gives you access to performing operations on this file. Right? Like for example, you should probably close it. By the way, I won't talk about closing later, but let's see what happens if I run this. All right, let me run this. Okay, cool. So I ran it. Okay, it doesn't look like it did anything, but in the background, it did. The Python kernel now has an open tab, right? And this is referred to as file handle. Right? So this is pretty much equivalent to saying, hey, Python, open this file, right? And then give it the name file handle, right? So we can start working with it. And yeah, you can look at the type if you want. You can look at the type of file handle. It'll kind of show us the class functions that are available to us. Right? So the type of this is something called a input-output wrapper. Right? You can look at this if you want. It's going to be a little hard to read though. Right? This is pretty much a class, and if you look it up, it'll tell you what kind of operations you can do on this file handle. Right? We're going to do something called reading and writing for now. Okay, so text IO wrapper. This is the base class. We're going to see some functions. The first function we're going to see is read line. So let me put it up here real quick. Yeah, we're going to see a function here called read line. Okay, so let's go ahead and use that right away. Okay, cool. File handle. Cool, so I'm going to go ahead and reopen it. Right, so here's another one. This is the same as above. So let me go ahead and run this. And then here it is, right? There's a class function called read line. All right, let's go ahead and see what it does. Right, so I'll press play here. All right, people kind of seeing what's happening here. All right, it grabbed the very first line in the text file. Right, so here's the text file. Let me load it side by side. Okay, cool. Just loading it side by side. Let me zoom out a bit. Hopefully people can read this. Let me know if you can't read this. Okay. So yeah, here, this is the text file, right? By reading the line, it grabbed the first line here. And you can tell that this function returns a string. Right, so you see how Jupyter Notebook is saying, hey, the result of this function is a string. Right, it's a string. You see these single quotes, and then this new line. You might remember this just says go to the next line. Right, there's an invisible new line over here. Right, after this example.txt, there's like an invisible new line, right, which is pretty much a character that says go to the next line. Okay, it's just an invisible character. Okay. And if I were to run this over and over again, right, let's see what happens. So I could run this, press play, and there it is. Right, you see how it kind of seeked to the next line? Right, and I'll press play again, and there it is. We're on the third line. Right, press play again. Press play again, my bad. And then here, and then finally, let's read the last one. And so do you. Right, there it is. We're on the last line. Let's see what happens if I keep reading. So press play again, and there it is. It's empty. Right, there's nothing more to read. So I'll keep reading it, and you see how it's empty now. Right, you can run this over and over again. The file handle is at the bottom of the file now. Right, so the people kind of see what the file handle represents. It's kind of like a pointer, right? It's in the beginning, it points to the beginning of the file, and then as we read line over and over again, the file handle seeks, right? It goes forward to the next lines. Are people cool with this? Okay, and you could start this over if you want, right? There's no more to read. You could start over. You can just run this cell again. Right? If I were to rerun this cell, it's going to reset the file handle to the top. Right, so I'm just going to press play here again. Right, there it is. File handle now points to the top, and now I can reread lines in. All right, there it is. Then, okay, people cool with this so far. Reading files. Okay, cool. All right. There's another function here called read, right? Not read line. This read will grab everything, actually. It'll grab everything. So let me start over. I'm going to clear out the cell output. I'm going to start over, right? So press file handle. There it is, right? File handle now points to the top. Right? I'm going to skip this. I'm not going to read a line. I'm going to skip this and just do this read here instead. So let me read here and see what it does. Right? You see what's happening? It grabbed the whole file. Right? It's representing the whole file in a single string. So yeah, that's what the read does. It just literally grabs everything. It's kind of this is probably not a good programming practice if you're dealing with large data. Right? Because if you were to read a large file, it's very possible that this string could get very large. Right? Like imagine your string being a gigabyte large. That would be a lot. That would be a lot. So I'm pretty much saying that loading in with this read function is like grabbing the whole file and putting it into memory, which can be considered inefficient. But this read line does things piece by piece, so it's less space inefficient. Okay, and you can combine these two functions if you want, right? Like once again, file handle is kind of like a pointer. So if I were to start over, right here, let me start over. Let me clear cell output. Let me start over. So I'll press play here. Now file handle points to the top of the file, and if I were to read a single line, so let me press play here. See, there it is. I read a single line, meaning that the file handle is now kind of pointing at the second line. So if I were to read in the rest of the file here, right, it would give us the rest of it, right? Roses are red all the way to the bottom. Right, so yeah, you can combine these functions if you want. All right, people cool with this so far? Okay, cool. I'm kind of going ahead, but it's probably a good idea to close the file every time you open it. Right? It's kind of analogous to having too many open tabs on your computer. Right? If you have too many open tabs on a computer, like all of these right here, right, it could kind of bloat your memory and slow things down a bit. So it might be a good idea to close it. Right? So file handle dot close. Right, which pretty much means to press the X button here. Right, so it's saying press the X button. That's really what it's telling it to do. Okay. And yeah, once the file handle is closed, you can't really do anything with it. Right? If you were to run these above statements, it's probably going to error out because you have to open it. You have to open it before. Okay, any questions about this stuff so far? All we did was open up a text file that contains a poem. Okay, let's go ahead and put things together, right? Let's go ahead and put all these in one cell. Okay, so here's an example of reading the file and storing the lines. Right? Earlier, we didn't really store it. We kind of just read it over and over again and forgot about it on the next iteration. Right? But you can store it too, right? These read lines, they do return a string. Right, you can check the primary documentation for it. It's over here. Right, so in the primary documentation, right, remember I googled this up. This is the base class. You could look at the documentation if you want, like read line here. Right, see this function, it returns one line, and it's going to be a string. So we could store those strings into variables called like line, whoops, let me press play here. You could store it into variables called like line 1, line 2. All right, so here, let's get this ready. All right, so dealing with the same exact file, let me go ahead and open it. So I'm gonna type it. I'm gonna type it from scratch actually. It's good to practice your typing skills. So let me go ahead and open it. So open files, example.txt. And then I'm gonna open it up in read-only mode. All right, once again, you don't really need to specify the read-only mode because it's like that on default. I'm just doing it to be more explicit. All right, just so folks are aware, I'm just gonna pull up the documentation again. All right, so the open function, right over here. All right, so this is the primary documentation for the open function, and this is pretty much saying that the mode is read-only based off default. Right over, I'll highlight it here again. All right, so this reading primary, it says it'll default to R. All right, so you don't have to say it, but I put it in anyways. Okay, so cool. So this is saying, hey, open, right? And then I need to give it a name so I can access it later. So I'll name it file handle. Okay, and it is a good programmer practice to close for every open. All right, this isn't talked about until later in the notebook, but I'm gonna go ahead and do it right now. All right, it's kind of like saying for every open parentheses, you want to close it right away. Right, it's pretty much the same thing. Cool. So I'm gonna close it, and in between it, right, while the file handle is open, I'm gonna go ahead and store the lines into some string variables. Right, I'll just call it like line 1. So you go to file handle.read line, line 2, and then this is still kind of hard coding, by the way. This is hard coded because we're assuming that the file has 4 lines. It's not guaranteed that every file has 4 lines, but this is just for demonstration purposes. Right, so this is saying, hey, read 4 lines. Each of them are going to be stored in these variables, and I might as well just print them out. So you can actually close it and then print it after, right? Because once you store the strings, you're pretty much done with the file. Right? So you can go ahead and close it to save some memory. Right, close it, and I'll print it here. I'll print lines, and then let me do a new line here, /n. Right. Actually, I'll do that in a bit so folks know why I did it. All right, so let me do that in just a bit. So lines, line 1. All right, because if I don't do it, it's gonna print it. It's gonna print the first line next to here. All right, so you see what's happening here. I open up the file. I have 4 variable strings, and then I'm just kind of dumping it out. So I'm gonna put a new line here after this lines. This way, this first one will go to the next line. All right, it'll just make it a little neater. So let me press play again. There we go. You see what that new line did? Are people cool with this so far? Right. So this is putting everything together. Right. It's opening a file. It's reading the lines, but it's storing them. Right. It's storing them so we can work with them later. Right. We ended up closing the file because we're done with the whole file, and then just kind of dump it out. Are people cool with this stuff so far? Okay. Cool. There's a more general approach to do this, by the way. This does kind of assume that the file has 4 lines. If we were to work with larger files that has more lines or less lines, right, you might want to generalize this approach a bit. So this is where a cool Python feature you can use. Right? You can pretty much convert a file handle to a list. Right, so here, let me start from scratch again. This is a kind of a more general approach. So let me open up the same exact file. So open files example.txt. I'll do in read-only mode. And this does return a pointer. It's not really a pointer, but it's kind of like it. Okay, and in good program practice, make sure you close. Right, always close for every open. Otherwise, you have something called memory leaks. So one of the cool perks in Python here is you can kind of just create a list right away by saying, oh, file handle, right, and then wrapping it in a list. Right, so this is Python saying, hey, convert this file handle to a list. So this does return a list, so I should probably store it. Right, I'm going to store it in a variable called lines, and there it is. Right, that's all you have to do. So check this out. So let me press play. Right, it doesn't do anything yet because I never really outputted anything, but you could print the lines now. You can literally just say print lines. Right, and then let's go ahead and look at it. All right, see, this is a list. Right, we were able to convert a file handle, and this is more general. Right, it's going to work with any size file. Right, if we have like a 100-line file, this list will be 100 lines, 100 elements. I mean. Right, so you could print things one at a time if you want. Right, you can say, hey, print lines at 0. Right, you could say print lines at 1, then 2, and 3. All right, see how it's printing all of the individual elements? All right, people cool with this so far? Okay, so yeah, this is really the same as above. It's just a little more general. Okay, any questions about this so far? Okay, with that in mind, we have enough to get 2 questions done in the lab. So let's go ahead and try to get the lab open. And then after that, we'll move on to the opposite of reading. Right? Opposite of reading is writing. But let's make sure folks can at least read a file first. So let's go ahead and open up the lab. Okay, lab number 13. And there it is. Okay, cool. Let me go ahead and load this first cell in. All right, so you should be able to get number 1 and number 2 done, right? Pretty much open and read a file and then read some lines. But not number 3 yet. Number 3 is writing a file. You could try this if you want to get ahead of the game, but let's try to get 1 and 2 done. So at the top of this notebook, there is a cell that will create a file for us. Right? You don't really have to understand this yet, but yeah, here, look, check it out. So on the left, you see our labs. There's no text file in here. Right? I'm kind of scrolling up and down. There's no text file. But when I run this, right, when I run this cell, it's going to create a text file for us. Right? You'll see right here. So let me refresh this. There it is. So I kind of just refreshed it, and then here it is. You see this file here, right? Test.txt. That's what the cell did. Right? It created a file for us that we can work with. Right? So you could look at it if you want. Right? You can double click here. Right? It's just a text file with 3 lines in it. The goal of number 1 and 2 is just to work with this file. Right? Just to kind of open it and see if you can navigate it. So here's the lab, right? Number 1, it says create a file called test.txt. This is already created for you, right? You don't have to do this. The previous cell did this for you, right? So you don't have to create a file. All you have to do is read the file and print the first line in the file, right? And then number 2 is pretty much the same thing, right? It's read and then print the first 2 lines. Okay, so go ahead and give that a shot. I'll give it like 10 minutes. And then after that, we'll do this together and move on to writing files. Okay, I'm going to put a 10-minute timer. Okay, welcome back from intermission, folks. Hopefully you gave the first two a try. All right, number 1 and number 2. Let's go ahead and do it together. So all these are really asking us to do is open a file and kind of print some stuff in that file. So this one, we want to go ahead and open up the test.txt. Right, it's already created for us. So let me go ahead and open it up. All right, so open test.txt. And I'm going to open up in read-only mode. Right, you don't really have to specify it. Okay, cool. There it is. Open. This does give us. It does return something. Right. I'm going to store that something into a variable called file handle. And then make sure you close it as well. Every open must have a close. Okay. Cool. So this one just says, read only one line and then print it out. Right, so we saw that in the lesson. Right? There's a read line function. So read line. Right. See this function. This is gonna return a string. Right. We should probably store the string because it's not gonna print it out. Right. Like it will print it out if I leave it as a last statement. Right. See, if I press play, it kind of prints it out. It's not really printing it out though. Right. It's pretty much saying the result of this last run statement is this string. It's not really being printed out. And just to prove it, right, if I were to uncomment this close out, it's no longer gonna display it. Right. See, it no longer displays this because it's not the last statement anymore. So just make sure you go ahead and print it. Save it first. So I'll save it as line 1, right? And then we can go ahead and print it. So let me go print it here. Print line 1. Right, there it is. All right, so this is opening up the text file. This one right here. Right. So it's opening it. The file handle points to the top. So we're going to read a single line, store it, and then close the file. Right, close the file, and then print it. Print out whatever we stored. Just a singular string. Okay, hopefully people are cool with that. Okay, next one this is literally the same thing, but do 2 lines instead. Right, same thing. So let me go ahead and open it again. Right, so open test. Let me use single quotes actually. It doesn't matter for this case. Single quotes or double quotes. Read only. Okay. Store it into variable. Right. File handle. And then good program practice, close it. All right, always close for every open. Okay. It's kind of like if you come from different programming languages, like C. C, there's kind of like a philosophy. For every allocation, you must delete it. Right? It's talking about memory. This is kind of related, right? Whenever you create memory, you should probably get rid of it. Right? Otherwise, you have something called a memory leak. Okay. So we're going to read 2 lines. Meaning that we just have to do the read line twice, right? Line 1 is equal to file handle dot read line, and just do this again. Right, there it is. So it stores the 2 strings, and now we just have to print them. So let me just print them in one single print statement. Print line 1, line 2. There it is. And perfect. Cool. It looks like it printed. Let me test it. All tests pass. Sweet. Okay, any questions about this so far? Okay. Let's move on to the opposite of reading. The opposite of reading is writing. Okay, so let's go back to the previous notebook, the lessons. Okay, I do want to point out that writing is a little dangerous because when you open a text file in write mode, the first thing that one of the first things Python will do is erase everything in that file. So be careful when you're opening a file for write-only mode. Right? Basically, the Python process is going to clear everything in the file in preparation for writing new data for it. So let me go to the lessons directory, right? So we can see what might happen. Okay, so I'm going to go to the lessons directory, right? Because our files are relative, right? So just to kind of prove it real quick, let's say, well, first here, let's open it. So this file doesn't exist, right? You see output.txt, relative to our current working directory, there is no output.txt here, right? But what happens if we opened it anyways, right? So if I were to open output.txt, right? First of all, if I were to open it in read mode, right? What do you think would happen? Right? Just forget about writing for now. Right? If I were to say, hey, open up this file in read mode, right? What do you think might happen? Right? Let's see. Okay, so it says file not found. Right? It says, oh, output doesn't exist. This makes total sense, right? Because in this current working directory, there is no output.txt. Right, so yeah, this error message makes sense. But if we were to change this read mode to a write mode, let's see what would happen. Right, so there it is. I'm going to change it to W, meaning this is going to be for write mode. So let's go ahead and write it. So press play, and there it is. I just pressed play on this line. There's no errors. All right, what did it do though? You see here, there's a brand new file here. So looking at our lessons directory, there's a file called output.txt. Right, that's kind of what this did. It since this doesn't exist and we are using write mode, it's just going to make it exist. Right, so it made it exist right here. It created one called output. And I forgot to close it, by the way. I should have closed it. So this does give you a file handle. And let me go ahead and close it so I don't have any leaking memory. Okay, so I'll just run it again. There it is, right? It just opened up this file. There's nothing in it. All right, check it out. If I were to double click it, you see it's an empty file. Right? There's nothing because we never told the file handle to dump any data into it. Right? Okay, I do want to talk about this danger though earlier. Right? Remember earlier I was saying that this has the ability to clear out the file? It does. Imagine if this output file had some data, right? Like let's say here is some data and something, right? That doesn't matter. But yeah, I'm just typing in some random stuff here, right? And then let me save it. Right? See this circle here? This circle means it's not saved. So let me save, Control S, boom, there it is, I saved it. Okay, so just to prove it, right, if I were to double click into output, this is now a text file with data, right? But what do you think will happen if I were to open it in write mode? Right, so this is dangerous. I want to keep specifying this. All right, let me run this cell and see what happens. So let me run it, press play. Okay, cool. I pressed play, right? Opened it with write mode. It doesn't do anything in between, but it just closes it right after. Right, let's go ahead and look at what the file looks like now. So output.txt, and you see how it's empty now? This is kind of like the default behavior whenever you use the W flag. Right, the W flag means get ready to write new data to it. Right, it is possible to have Python not erase it. Basically, you want to use something called the append mode. Right, you can use something called A. Right, this is short for append, meaning that the file will still stay the same, and we're just going to add stuff to the bottom of the file. Right, but for the sake of this lesson, we're just going to talk about reading and writing. Right, reading and writing. We're not really going to talk about appending, unless you want to. Okay, so yeah, hopefully people see what's happening here. Right, be careful with this. Please be careful, because you don't want to be opening up some homework, right? Like let's say you were to accidentally open up your homework, right? Like let's say you had a homework1.ipynb, right? ipynb is a notebook file. So if you were to accidentally open up your homework file in write mode, it's going to clear everything in it. Right? So be careful. Okay. Any questions about this? Okay, cool. So we were talking about writing, right? This file handle has the ability to dump data into the file, right? Because of this W flag, right? We are now able to use other functions like the function .write. Right? This is a class function which takes a argument. I think you can put anything in here. Let me actually look at the documentation for this. So let me look at the write. File handle. Where's the write? Here. Okay, I think I have to skim through the documentation a bit. Basically, I gotta look at previous bases. But anyways, if you were to dive down the documentation a little longer, you'd find a function called a .write, which takes an argument. It can take a string, like you can say hello world, right? You can say hello world, and this string will be dumped into the file handle, right? The file handle is pointing at the top of output. So let's test it, right? I'll press play. Right, so there it is. I press play, and I need to reload this output.txt, right? Because it's showing the previous one. So let me quit this. Let me quit the output and reload it right over here. Right? Reload it, and you see it. See the function wrote the string here. Now you can write more stuff if you want. Like if I were to say file handle dot write testing 1 2 3. All right. When I rerun this cell, once again the whole file will be cleaned up. Right. It's going to be cleaned up, and then we're going to write this data over it. So I'll press play, and then go ahead and check the output. So reload the output, and there it is. All right, see, it literally dumps the two strings into here. Right, there is no new line because the write function isn't really like the print. Right, so the print function in Python will put a new line at the end of it for us, but not the write function. Meaning that we have to manually say new line, right? /n. This is an escape character, which means get ready to go to the next line. Right, so this new line here, let's see what it does now. So I'll press play, there it is, and then reload. And there it is, right? There is an invisible new line right here, right? You don't see it, but there is that character, new line. Okay, people cool with this so far? So this is how you kind of write. Okay. Cool. Oh, yeah, and it says, yeah, okay, we already did this. By the way, if I were to try running this, it's not going to run. Right, it says, why do you think it's not going to run? Right, try to give it a guess. Right, let me paste this here and try to run it. Right, why do you think it's not going to run? So let me see. Yeah, see, it says it's closed. Right, this is because I closed it earlier, meaning that file handle no longer points to anything really. So yeah, that's not going to run. Okay, hopefully people are cool with this. All right. I do want to specify that these write functions do return something. We just aren't really doing anything with it. This does return a number. It returns a number that represents how many bytes were correctly written in. So this might be useful for like loading bars, right? Like sometimes it's necessary to keep track of how many bytes were being written, right? So let me go ahead and store this, right? Like imagine that there is some number that's named bytes written, right? I'm going to initialize it to 0. You can imagine this as a loading bar, right? Imagine a loading bar that starts at 0, and then when we write to the file, the loading bar should increase, right? Because we're done doing something. So this does return a value, right? It does return a number, and this number represents how much data was being written, right? So we could store that into, we can accumulate it actually. We can say bytes written plus equals, right? Plus equals, this is a shorthand notation for saying bytes written plus this right here. Right, so there's two things happening here on this line. Right, the first thing that happens is this function, because the order of operations, right, the parentheses are here. So we're gonna write some data, and then this does evaluate to some number, right? So like you can imagine that this whole function collapses to some number, right? It's gonna collapse to actually 5, 10, 11, 12. It's going to collapse to 12 because there are 12 characters here, right? You can count them, right? 5 plus 1 plus 5 plus a new line character, right? There's 12 characters. So this is going to resolve to 12, right? So I just kind of replace it with 12 because that's what it returns. And we're kind of just accumulating it, right? But so let's see. Let's do the same here, right? Bytes written plus this. Okay, it's cool. Let's test it. Okay, let me print it here. Bytes written. Okay, there it is. Let's test it. See, bytes written is 23, right? Which makes sense because that's how many characters were written. If you're curious what a byte is just really how large data is, right? In this case, it just happens that each character is worth 1 byte. Right, so just to prove it, I'm gonna kind of comment this out here. Right, let's say we were only to write 1 line. So let me test it here. Right, see, I just only wrote 1 line, pressed play, and it says 12. Right, does that kind of make sense? Because this is saying 0 plus 12. Right, so yeah, people kind of seeing what's happening. Basically, this is useful for maintaining loading screens. Because sometimes you want to let the user know how much was successfully written. Does that kind of make sense? Okay, cool. And there is a shorthand notation to writing this right here. You can literally just say plus equals. Right? Plus equals is a shorthand notation for accumulating the numbers. So it's the same thing. Okay, cool. So bytes written is 23. Okay. Cool. Once again, it might seem kind of useless, but one use case is for loading bars, and another use case is for determining whether or not it failed, right? Like let's say you wanted to write like a certain amount of bytes. Maybe you want to do a sanity check in the end, right? You want a sanity check to make sure all of the data was correctly sent over, right? So this is useful for like maybe checksums, or if you're curious what a checksum is. A checksum is a way of kind of determining that communication was successful, right? You can determine communication is successful if the bytes written is equal to some number. Okay, hopefully people kind of seeing why this is useful. Okay. Okay, cool. This stuff just went over what we talked about. Just to do it one more time. This This is literally just going to do the same thing, but in a different style. So you can maybe imagine, like, you have a name that's equal to some value. I'm just going to say Bob. And then maybe we want to, for some reason, dump that name into a text file. Right? So you could say, hey, let's go ahead and open a text file. All right, I'll call it greeting.txt, open in write mode. Right, this greeting.txt doesn't exist, by the way. Right, it doesn't exist in our relative directory. So it's going to end up creating it, meaning we can store it in a file handle and then do some stuff in between and then close it later. Okay, in between, I'm just going to dump out some random info. Like, I'm just going to write like a greeting, right? Like the same stuff up here. I'm just going to write something like an F string. Hello, my name is, and then the variable here, and a new line. New line so we can get ready to go to the next line. Okay, cool. So this does return, this will work, by the way. It's going to dump info out. So let me test it real quick. Press play. Okay, there it is. I press play. There's no output, but there is an output file down here. Right over here. See, greeting just created. So let me open it, and here it is. Right, it's just a text file with a single line in it. Okay, and we just talked about kind of storing how many bytes were written. So you could take advantage of this function's return value and store it into a number. Right, you could say, you could store it into some variable called wrote. Right, this is really just representing how many bytes were written. And then if you want, you can print it in the end. In the end, you can say like print total bytes written, and then wrote. Right. Oh, this needs to be an F string. Okay, cool. Let's test it. So press play, and yeah, it says total bytes written 22. Right. It's 22 because each character is worth a single byte. Okay. Any questions about this so far? Okay, cool. Finally, a couple more things. We already talked about this. This should have been talked about a lot earlier, which is why I kind of talked about it in the very beginning. But yeah, closing the file handle, this is to prevent memory leaks. It's, once again, the analogy is you don't want to have too many open tabs. When you're done with a tab, you kind of want to close it. Right? Like, I know I'm kind of contradicting myself because of all these open tabs up here. But let me quit them. Let me quit them. See, this is closing. It's like closing a file handle. Right? That's pretty much what I'm doing. It's useful, so your program can run a little faster. Okay. I mean, not faster. It can run more space efficient. Okay. Cool. So you know what? We actually have enough to get the rest of the lab done. We just finished talking about writing. That's enough to get the lab done. So you know what? Let's not go to the lab yet. Let's actually just finish the rest of the lesson. There's just a few more fun stuff in there, and then I'll let folks try out the rest of the lab at home. So we talked about reading files. We're done with this. Talked about writing. Now there's some fun stuff here. It might have been pretty boring because we've only been dealing with text files, like this greeting.txt, right? It's just a text file. It's, you know, let's deal with other things too, right? Like maybe pictures, right? So you might have seen these extensions before, right? Have you ever like looked at data, maybe your iPhone data, and you've seen that pictures are stored in like a .png or JPEG, right? These are just, whoops, let me play this cell, my bad. You know what I mean? These are file names, file extensions that represent the format. Like the PNG file. Earlier I downloaded this Cabrillo logo. Right, this Cabrillo logo is a JPEG, right, JPG, which is just a format on data, on image data. So we can open up these files as well, right? You just have to kind of use a different library to decode it. Because, like, look at this Cabrillo College logo.jpg, right? What do you think would happen if I open this up in a text editor? It's going to be pretty ugly. So check this out. Let me right-click this Cabrillo logo and just open it in a text editor. Oh, okay. It doesn't even load because the format of the file isn't really supported by the Jupyter. But let me force look at it. So let me download this. Okay, I'm gonna download it. I'm actually just gonna load it up. I'm forced to look at it. So let me go CD downloads. I'm going to use my text editor to look at the Cabrillo College logo. So Cabrillo College logo, JPEG. And you see how I kind of opened up the file. It's kind of hard to read. The reason why is because the file is represented in bytes, or binary, I mean. And my text editor tried its best to represent the binary as characters, but it's not really suitable because the encoding is a little different. So there are libraries that are able to translate the binary correctly. Like our Jupyter server here contains a library called PIL. I'm not sure what this stands for. Probably something image library. And this library will kind of decode the file for us, right? Like this labs files maze, right? Let's take a look at this. So let me take a look. It is relative, by the way. It's relative to the lessons notebook. So the lessons notebook is right here. Period. This means go backwards. So this is like saying go back, and then go into labs. All right, go into files, and then maze. I'm curious. Let me open this up in a text editor. Is this going to show up? No, it's not. Okay, because it's not the right encoding. But if we use this image library, right? Let's go ahead and use it. From PIL import image, we're going to be able to display things in our notebook. And I think this is, let me try it out real quick. Okay, cool. Let me run this. Okay, image. Oh, it didn't do anything because I need a display pic. So let me display it. There it is. All right, display pic, and it's showing it, right? Display is just a fancy print. Okay, cool. So we display that. Let's display some more things, right? Like let's say pic is now equal to something else. Maybe pic is now equal to the Cabrillo College logo, right? So Cabrillo College logo is located. It's located over here. Right, it's backwards. Right, so go backwards, and then here it is, right, into this Cabrillo College logo. So backwards, and then Cabrillo logo.jpg. Right, let me go ahead and display that. Right, there it is. I just pressed play, and now it's going to show two photos. Right, pretty cool stuff, right? Just kind of accessing files. Okay, cool. So yeah, once again, this is a library that handles the decoding for us. I don't want to jump too much into binary stuff, but the Cabrillo College logo, each pixel is kind of represented as some bits. So this library is taking the bits and bytes and translating them into actual colors. It's pretty cool stuff. Okay. Cool, so we talked about a couple different files, right? One is plain text, We talked about image files. We use the library to handle this. You can open up other files too, like music. Right? Music is typically represented in these extensions, right? MP3s or .wav. Right, so here's some examples down here. I don't think you can hear this if you're. I don't think I have the right setup for this, but if you try this out at home, you should be able to hear it. Right, so I'm importing a interactive audio library, which will let us have a play button. It's like a widget. Right? I'm really importing a widget that can play a file. Right? So in this case, it's going to go into files over here, and then conga groove. Right? That's what it's doing here. So let's go files and then conga groove. This is an audio file, and then. Do I display sound? I forget if I display. I think I have to display it. Oh yeah, let me try it. So press play, and there it is, right? I displayed the widget. I'm not sure if you can hear this. Yeah, I'm not sure if you heard that, but if you try it out at home, you'll hear it. Cool. So yeah, that's an audio file. Finally, there are some other types of data. There's something called a CSV, which stands for comma-separated values. And then there's another one called XLSX. These are pretty much the same. They're at a high level, they're really the same. You can just think of them as like tabular data. Like, if you ever worked with sheets before, like maybe Google Sheets. Let me bring up my Google Sheets. Oh, hold up. I'm actually going to hide this real quick. I don't want to leak any data. Let me bring up my sheets. Give me 1 second, folks. Okay, cool. So imagine you're working with some sheets, right? And maybe you want to download it later. So let me just have a sample scenario. Like maybe, let's say this sheet is going to store, let's see. I guess you could think of this as a grade book. There's a lot of different use cases, but you could think of this as like a sample grade book, where each row kind of represents a person, right? Like maybe this is Alice, and then Alice has like an 80, has a 90 here, has a 95 here, and maybe Bob has like a different 70, 100, 20, and maybe a Charlie has all 100s. Right, so this is just a sheet. It's a Google sheet. Right? You can download this, and it'll be in certain formats. Like if I were to download right here, you see all of these formats that I can download it as. Right? I can download it as a Microsoft format. This is for Excel. Right? I could download it as CSV. I actually use these a lot. CSV and TSV. These are pretty much the same thing. If I were to download it as comma-separated values, let me take a look. All right, there it is. I just downloaded a CSV file. If you were to look at it in plain text, it looks like this right here. All right, so I'm looking at it. This is the file I just downloaded to my computer. All right, it's possible to use a library to load this into a data structure. All right, so let me show you what I mean. I'm going to upload this file to the Jupyter notebook, the Jupyter server, I mean. All right, so I'm going to go into Jupyter server, and let me, I guess I'll upload it to this directory, the lessons and then the files. All right, let me go ahead and upload it. So here it is, sample gradebook. Let me rename this. I'm I'm gonna rename it so it's easier to type. I'll just say sample underscore gradebook. Okay, cool. So here's our sample gradebook that I just rendered from Google Sheets. Right, it's right here. You can open it in a text editor if you want. Right, editor. Right, this is how we downloaded it. Right, so there's a library called Pandas. Right, Pandas is short for panel data. Right, I know it sounds like the animal, but this is a library that kind of lets you read in tabular data. So if I were to import something called Pandas, right, so import Pandas, this is going to let us kind of read and format at the same time. Like I could say pandas.read CSV, and then this is actually going to do two things at once. You won't really have to know this yet until like a few more weeks, but this is opening and converting at the same time. Right. In particular, I'm going to open up the sample gradebook. So it's in files, and then it's called sample gradebook.csv. Right, so I'm opening this. This does do two things, right? It opens and then it converts it. Right? It's going to convert it into something called a data frame object. We haven't talked about data frame objects before. It's really just a fancy dictionary. Right? So think of DF as a fancy dictionary. And let me go ahead and put DF here. So Jupyter Notebook shows the result of this. So check it out. Check it out. It's pretty cool. See, so I'm pressing play here, and check it out. Pretty sick, right? I do need to modify some stuff here. So the way I rendered the table, the pandas library is treating the first line as the header. So here's what I mean. My sample gradebook right here, I didn't have a header. Right? I was supposed to insert another row here that kind of describes a column. Right? I was supposed to have it say name, and then maybe homework 1, and then homework 2, and then homework 3. Right? So this is the header. I forgot to put that in, which is why when Jupyter rendered it, right, it's making these bold. So let me go ahead and refresh this. I'm going to re-download this. So let me re-download this CSV file, and then let me overwrite it. So delete this one, bring in the new one, rename it sample gradebook. Okay, so I just got the new file. This file has some headers here. Right? This is what the raw file looks like. And then now the panel, the pandas library should read the header correctly now. So let me press Control Enter, and there it is. Right? The DF, this is our fancy dictionary. Right? You could print it. It's going to look a little less formatted. Right? See, same thing. It's just the tabular data. So this is some pretty cool stuff, actually. This is useful for like data analysis. Right, like in a couple more assignments, we're going to have some data analysis projects where we use larger data to perform statistics off of it. Like MLB players, there's a lot of Major League Baseball players. So sometimes you might find yourself creating a data structure from it. Right, see, there's the file, it's called Major League Baseball players. This is a file that contains, it's an old file. Here, let me show you what I mean. Right, it's an old file. Pretty much, I'm not sure what year it is, but it contains 1,034 players. I'm not sure what year it is from though. It might be an old one. Okay. Anyways, you don't have to know too much about pandas. There's literally a whole lesson dedicated to this. It's coming soon. It's coming around here. Lesson 18 data science. All right, we're gonna be doing some pretty cool stuff here. It's gonna involve panel data. Okay. Cool. So that's about it for today. Let's kind of summarize the biggest takeaways from today. Right, the biggest takeaway is really just reading and writing files. That's really it. You should have enough to get this lab done now. Let me take a look at it. So we already got number 1 done and number 2. I would like folks to try out the next ones. Number 3 is asking if you can write a file called fish and then kind of dump some data into it. Right, so see if you can do that. And then some more reading and writing. Read. Okay. I'm trying to see if folks will have a hard time with this. Okay. Folks should have enough to get the rest of part 1 done. Right, part 1 is pretty long, but you should at least be able to get this one done. Number 3, right, write a file. Number 4, read some lines and then print them out again. Number 5, read a file. Number 6 is also reading. Yeah, so it looks like most of this is reading files again. So see if you can do that. Part 2 will be a little harder. But before the next recording, can folks at least try the part 1 out? Right? These labs are actually designed for folks to get done themselves. But I do realize that sometimes the questions are ambiguous. So I will go over these questions on Thursday. Right? Please try it out yourself, though. If you're on the recording, try it out before watching the next recording. Right? So on Thursday, I'm gonna go over the rest of this lab, right? The rest of part 1, all of part 2, and then we'll go on to the sneak peek on the next programming project. The next programming project I already have released. It's pretty much a Mad Libs. Right? Have people heard of Mad Libs before? Right, here, let me pull up the project real quick. Actually, I'll pull it up in the next recording. So the next project is Mad Libs. If folks have ever played this in their, elementary school years, you can think of Mad Libs as a story generator, where you can imagine you open this book, and then there's a template stories in there. Right? There's lots of templated stories, meaning that the stories are not done yet. Right? You have to kind of partner up with a person or a group, and you got to ask the group, be like, hey, give me a noun. Right? And then whoever gives you a noun, you'd write it down. And then you would say, oh, okay, now give me a verb. And then whoever gives you a verb, you'd write down the verb. All right, and keep on filling the blanks. And then once all the blanks are filled, you would read the story out. And typically the story would come out not making any sense because the other players have no idea what the story looks like. So let me see if there's an online game that I can play real quick. Never mind. I'll just talk about this on Thursday. I just need to make sure nothing inappropriate shows up. So I'll screen it later. But yeah, we'll do some Mad Libs on the next program project. It's going to involve reading files. Right? Imagine files that contain stories. Okay, that's about it for today, folks. We're gonna end like 5 minutes early today. Hopefully people are okay with that. Okay, thank you all and have a great night. Bye-bye.